Hello and welcome to my mid-semester walkthrough for MySH. My name is Tanish Roy, and in this video I'm going to demonstrate that my code compiles without warnings or errors, show how my shell handles variable definition and redefinition, illustrate variable expansion, including expansion within another token, and explain how I store environment variables dynamically. I'll also cover my approach to handling expansions that exceed 128 characters. Let's dive in. So I'm going to first begin by showing you that my code compiles cleanly. So here's my makefile, and I'm just going to run the make command. Sorry, I should run make clean first and then run make. And you can see that my code compiles with no errors. And in my makefile, you'll see that I'm using all the flags, wall, wextra, and werror. So everything is compiling cleanly with no issues. And now we're gonna proceed to the variable definition and redefinition part of the video. So first I'm gonna start running my shell, and now if you see I type in my var equals to hello, and in the code this command calls the set variable function in variables.c, and it checks if the variable already exists in our dynamic array of environment variables. And since my var is new, it added the value hello. So now when I type echo my var, it gives the output expected of hello. So the shell basically is calling the expand token function, which replaces my var with hello using the get variable function. And as I said before, the output is hello. And now if I redefine my variable by entering my var equals to hi, again, the set variable function is looking for the existing my var and finds it. So it frees the old value and updates it with hi. And if I now echo my var, it is updated to have the output of hi as expected. So this clearly demonstrates that both variable definition and redefinition are handled correctly by my shell. Now I'll show how variable expansion works with another token. So we'll begin by defining two variables, greeting, which I'm going to set to hello, and target, which I'm going to set to world. And then if I execute echo $greeting, comma $target, the expand token function scans the input token character by character, and when it encounters a $, it reads the subsequent characters to extract a valid variable name. And for greeting, it retrieves the value hello, and for target, it retrieves the value world. And these values are concatenated together with the rest of the token, resulting in hello, comma world as expected. So this demonstrates that the variable expansion within the tokens as implemented is as specified, and it meets the rubric requirements for the demonstration of variable expansion. So now I'm going to just explain and go through my code to explain how my shell stores an arbitrary number of environment variables. So in variables.c, I use a dynamic array of structures where each structure of type nvar holds a variable's name and value. And here's the approach. So in dynamic array and reallocation, I maintain a static pointer nvars along with counters for environment count and environment capacity. And when a new variable is added via set variable, I check if the array is full. And if so, I use realloc to double the capacity. And this basically just allows the shell to scale with the number of variables within the running program. And in order to handle redefinition, so before we add a new variable, the function iterates over the existing variables. And if the variable is already present, its value is updated instead of adding a duplicate entry. This keeps our storage efficient. This advantage of this approach is that it's simple and it has dynamic scalability. And on the downside, if many variables are added, frequent reallocations might incur some overhead. And an alternative might be using a hash table for fast lookups, but for this project scope, the dynamic array is sufficient and much easier to implement. And now I'm gonna go into showing how my code handles variable expansion exceeding 128 characters. So in the expand token function, I allocate a buffer size of max string length +1, which is just 129 bytes, and then append characters from the input token variable's value until either end of the token is reached or the buffer reaches 128 characters. This ensures that the result never exceeds the specified maximum length. Similarly, in get input, and which is in io_helpers.c, If the user inputs more than 128 characters, the function writes an error message. So the error message is input error input line too long, and it would just discard the extra characters. This truncation ensures the shell remains safe and compliant with the project description. So basically, this decision was made to guarantee memory safety and consistent behavior, and basically just prevents buffer overflows. While the downside is it may cut off longer inputs. However, the trade-off meets the requirements and ensures a robust implementation. So to summarize, in this walkthrough, I've demonstrated that the code builds without warnings or errors using the make file provided with the strict flags. I demonstrated the variable definition and redefinition. I've also shown variable expansion. So the variables are expanded within the tokens properly, as showed with the combine command. And also I have dynamic storage. So the environment variables are stored in a dynamically allocated array with scalable capacity. And finally, string truncation works. Both the user input and variable expansions are safely truncated to 128 characters to ensure memory safety. And thank you for watching my mid-semester walkthrough for MySH. I'm happy to answer any questions or provide further clarifications on any part of my implementation. Thank you.